Hello everyone, welcome to lesson 8-8, solving multi-step equations and inequalities. In this lesson, you will learn how to solve multi-step equations and solve multi-step inequalities. Let's look at a real-world link and then analyze how multi-step equations and inequality apply. Field trip. A field trip is a fun and exciting way to learn about something in a totally different way. Mr. Murphy's class of 20 students is going on a field trip to the Science Center. The total cost of admission and tickets for the 3D movie for all the students is $270. So that looks like our total and the number of students. If we look, this is the way we should analyze this real world context. So if X represents the Science Center's entry fee, the expression 20 times X plus $2.50 represents the total cost for Mr. Murphy's students. Suppose 15 of the students go on a field trip to an art museum where the entry fee is twice that of the Science Center's fee, and there is a fee of $1 for the audio tour. If the total cost for Mr. Murphy's students is the same as both museums, you can find the Science Center's entry fee by solving 20 times X plus 250 is equal to 15 times 2X, because it's double the price, plus the $1 for the audio. Now, I was just wondering, and you might have been wondering the same thing, where did the 250 come from? I am assuming that it's the admission fee, and then the ticket is what we are trying to solve. The tickets is X, and the admission fee would be the 250. Okay, so now we have two equations. As you can see there, we have the one museum and the other museum that's double the price. Okay? And then we solve, and we find that X is $3.50. Remember that in the first scenario there were 20 students, but on the second scenario there were only 15, right? This is what we are going to practice today, but if you'd like, you can pause and follow each step accordingly so that you feel more familiar with the content when I am doing it down here. Okay, so now let's jump right to the gadot section, and we have 1A and 1B. Before we do that, I would like to draw attention to this statement down here. Some equations have no solution. When this occurs, the solution is the null or empty set. Null is the more common expression, shown by the symbol 0 with a dash through it, or empty parentheses. Other equations may have every number as their solution. An equation that is true for every value of the variable is called an identity, which means all answers are possible or no answers are possible. So no, there's no answer, or all answers are possible. All numbers are a possibility. So let's see what they mean by that. We have 1A and 1B. Let's solve these. Now, you can pause the video now and try it on your own, and then play to check your answer. Pause now. Okay, I hope you paused the video. The first thing I'm going to do is I'm going to do distributive property on this side so that I can simplify my terms. So my second line will look like this. 12m plus 12 equals 6 times 3m is 18m plus 6 times 3 is 18. 18. Okay, so now I want to collect my like terms, but before I do that, I need to identify which side has the higher coefficient. Over here I have a coefficient of 18, and over here I have a coefficient of 12. 18 is the higher one, so I'm going to get rid of this one. So I will use subtraction property of equality to remove the 12m, and I have to do the same to the other side. So the 12m is gone, and I'm left with just my 12 equals 18 minus 12m. 18m minus 12m is 6m plus 18m. Okay, and now we must look right here and get rid of the 18 Okay, so that because we're trying to isolate the m, so let's subtract on this side minus 18, and you must do the same to this side, minus 18. Okay, on this side the 18s are gone, so I'm left with my 6m, and on the other side 12 minus 18 equals negative 6. Right, now I should use division property of equality and remove the 6 from both sides, and when I do so, 6 divided by 6 is 1, and 1 times m is simply m, and negative 6 divided by 6 is negative 1. Therefore, m equals negative 1. That's our answer. Let's try 1b. In 1b, we have 5 times n minus 3 equals 3 times n plus 7. Let's use distributive property first, right? We must use distributive property, multiply the number outside of the parentheses with the values inside of the parentheses. So we get 5 times n equals 5n, minus 5 times 3 equals 15, or negative 15 because it's 5 times negative 3, equals 5 times n equals 3 times n equals 3n, and 3 times 7 equals 21. Okay. Let's identify which side has the greater coefficient. This side has a coefficient of 5, and this side has a coefficient of 3. So we will keep this one and get rid of this one. So I will go ahead and use subtraction property of equality to subtract the 3n from both sides. And now that leaves me with 2n on this side minus 15 equals 3 minus 3n is gone. So I'm just left with the 21. Okay. Now I want to isolate this n. I want to leave it all by itself, so I will go in reverse order of operation and remove the minus 15 by adding 15's. Addition property of equality on both sides. And with addition property of equality, this side is gone and the other side becomes 36. 21 plus 15 is 36, and I have just the 2n. Now I will use division property of equality to divide both sides by 2 so I can isolate the n. And right there the 2's are gone, so I'm left with n, and 36 divided by 2 is 18. And there you have it. Okay, I hope things are starting to make better sense for you. Now let's take a look at a couple of equations where all numbers are the solution, and another equation where the answer is null. No solution. Okay, when we say that all numbers are a solution, it means no matter what number you replace y with on either side of the equation, this side of the equation will always equal this side of the equation. So it doesn't matter what y is. If it doesn't matter what y is, that means all numbers can be the possible solution. So over here, you can see that once we remove everything and we remove even the y's, we are left with 10 equals 10. Which really doesn't matter what y equals, because no matter what, this side will always equal this side. Again, you're welcome to pause the video and read through the steps carefully. And you'll see that 10 is 10 is always true. The equation is an identity, and the solution set is all numbers. So, identity. And then for b, we have null, which means when we solve the equation, you'll see that we have to get rid of the negative 5s, and on this side negative 5s. And once we do that, you'll notice that negative 14 equals 6. No, that's not true. Negative 14 does not equal 6. Because it does not equal 6, it will never do that. We have no solution, and the solution set is null. Okay, so those are the two scenarios when it would happen. We're going to have that here in 2a and 2b, so let's try it. Please pause the video, try to solve these two on your own, and then play the video to see my answer. Pause now. Okay, I hope you paused the video and you are ready to check your work. Let's see, 2a here, we have to use distributive property first, okay, on this side. And then we can also work with like terms simultaneously on the other side of the equation, right? To simplify the equation. So we have negative 2 times 3r equals negative 6r. And we have negative 2 times positive 4 equals negative 8. And that equals, on this side, remember, negative 5r minus another r is going to be negative 6r minus 8. Remember, I combined these two together to make it negative 6r. Now that I have negative 6r on this side and negative 6r on this side, we can see that we can remove the negative 6r's. And you can see the equations is already all answers are possible because we have negative 6r minus 8 equals negative 6r minus 8. So even if we make the r 1, we're still going to get the same answer. We make it 2, we make it 3, because whatever you replace r with on this side of the equation, you must do so on this side of the equation as well. So you can see that this is identity and all numbers are answers. All the numbers are possible. But let's continue on and you'll see what I mean. If we try to remove one of the 6r's by using addition property of equality, the r's are gone and I'm left with negative 8 equals negative 8. And that's always true. So this one is identity. Okay. All right, let's try 2b. For question 2b, we have distributive property on the top first. Okay, so let's solve that. So I will write my first line as 14 plus 8w equals 4 times 8 equals 32 plus 4 times 2w is 8w. Now I see that I have 8w and another 8w. I don't have one coefficient that's greater than the other. So let's just go ahead and remove the 8w on both sides. Okay, and that's gone. So on one side, I'm left with 14 equals, on the other side, since that's gone, I'm left with 32. And all right, but 14 will never equal 32. So our answer is null, which means there is no answer, no solution. Now we just solved equations and we're going to move on to solving multi-step inequalities. Inequalities are going to be very similar to equations, with the only exception that the inequality sign may flip if we are working with a negative coefficient or if the divisor is a negative. What I mean is, you'll see what I mean by that, but we don't have that example just yet. Solving a multi-step inequality is similar to solving a multi-step equation. As a first step, you can use the distributive property to remove grouping symbols. So that's what we have here, grouping symbol, which means removing the brackets. And you can see that's what they did here, right? 4 times x is x, and 4 times negative 3 is negative 12. So we have 4x minus 12 is greater than 6. Remove the 12 from both sides, and now we have 4x is greater than 18. So x must be greater than 4.5. Okay. That should make sense to you since we've already done inequalities in this chapter. So if you are ready, go ahead and solve 3a and 3b. Pause now. Okay, I hope you are ready to check so that we can check this one together. I see that I have 3 is less than. I'm going to use distributive property first, 4 times x, and then 4 times 2, which will give me 4x plus 4 times 2 is 8. Okay, let's use subtraction property of equality to remove the 8 on both sides. Well, that's not a nice 8. And that gets rid of my 8, leaving me with my 4x is greater than 3 minus 8 is going to give me negative 5, right? And now I will remove the 4 by using division property of equality on both sides. And when I do that, 4 divided by 4 is 1, and 1 times x is simply x. And on this side, I have to divide, and the best way to divide is by asking yourself how many 4s are in 5. I already know that my answer is going to be negative, so I'll put my negative there. How many 4s are in 5? I have 1 whole 4. Then from 4 to 5, I have 1 left over, and it's all over 4. So it's negative 1 and 1/4. And to write it properly, we want to write it with the x on the left side of the inequality is greater than, it's greater than, right? Negative 1.25. I changed it to a decimal just for fun. And now we have 3b. Again, we have distributive property first. 4 times b and 4 times -3 would give me 4b, and 4 times -3 is -12, is less than or equal to 72. Let's use addition property of equality to remove the 12, and we must do that to both sides. That's the property state. That's a property of equality. 12's are gone, so I'm left with 4b is less than or equal to 84, right? Yeah, 84. Now let's remove the 4 by using division property of equality. And when I do so, 4's are gone. I am left with b is less than or equal to, this looks like it would be 21. So b is less than or equal to 21. I hope you got those answers correct. And lastly, we have example 4, which is a word problem. So putting this skill to a real world context. Mariela's parents have budgeted at most, the very most, $575 for her quinceañera celebration. Quinceañera is when a girl turns 15. It's a Spanish celebration of when a girl becomes a woman, right? That's usually a relatively big party. So at the very most, they've budgeted $500, no more than that. So this is the maximum amount. Whatever they want to use should be less than this amount. The cost of the party room is $75. How much can the family spend per guest on food if each of the 40 guests receives a $5 favor, like a party favor? So we've got 40 guests, right? 40 guests, and they're each going to receive a $5 party favor. Okay, it has the maximum amount that can be is $575, and we already have to add the cost of the room. So this is what it would look like. So we have a maximum amount of $575, right? And then everything else has to be equal to or less than. So we have the $75 room plus the 40 guests, and each guest is going to receive a party favor of $5, and we have to see how much we can afford to spend on them in terms of entertainment and decorations and whatnot. So that is the inequality. Now this in itself is a skill. To be able to take a context and put it into an algebraic expression or an algebraic inequality is a skill. And there we have it. These are the steps we've been doing. Okay, so we figured out that 7.5 or 750 is the most that can be spent on food per guest, which is not really it's not very much, but okay. Let's take a look at question 4. All right. Oh, I didn't realize there were 5 examples. Sorry, I thought example 4 was the last one. Let's solve question 4 together. Sophia recycled 3 pounds less than the amount that James recycled. Okay, so Sophia is James minus 3. You get that? So Sophia recycled 3 pounds less than the amount James. So James minus 3 is Sophia. Hannah recycled 3 times the amount that Sophia recycled. So Hannah is 3 times J minus 3. I get that. If they recycled a total of 53 pounds, how many pounds did Sophia recycle? So let's write what we know. We know Sophia recycled 3 pounds less. Okay, so 3 pounds less than the amount James recycled. Then James. Hannah recycled 3 times the amount that Sophia recycled. So Hannah recycled 3 times the amount. So that's going to get multiplied times 3. That's Hannah. If they recycled a total of 53 pounds, so together, oh, wait a minute, though. I have to have 2 J's. Sorry, that's my mistake. I'll explain again. Let me go all the way back and start over. We have what James recycled, right? James. And then we also have what Sophia recycled, which is James minus 3, right? And then we have Hannah recycled 3 times the amount that Sophia recycled. So I know that she recycled this amount 3 times. right here, this amount, 3 times, right? There we go. So that's 3 times. But we are forgetting to include Sophia. So we should probably include Sophia one more time. There we go. That would be, this is Sophia, this is James, and this is Hannah. And all of that is equal to 53 pounds. Does that make sense? Okay, we have right here Sophia all on her own. It's 3 pounds less than James. James collected his amount. And then James minus 3 times 3 is Hannah. Now, this looks a little sloppy. So we can make it a little less sloppy, okay, and by combining all of the like terms. So let's just solve a little bit. I have a j here and a j here, so I know I have 2 j's minus 3, and then I will do distributive property with Hannah's so that I have my 3j, 3 times j, and my 3 times 3 right there. So that would be plus 3j minus 9, right, equals 53. I can continue to consolidate these, and I have 2 j's right here, 2 j's plus 3 j's equals 5 j's, and then I have negative 3 and negative 9 equals minus 12, right? Minus 12 equals 53. Now this looks like it's easier to work with, right? So I will use addition property of equality to remove the 12, and that gives me 65, right? 65 on this side, and I have 5j on this side. 5j. And then I would have to divide both sides by 5, and that gives me j equals 13, right? So that means that James had 13 and Sophia had 10, and so if James had 13, Sophia has 10 because she has 3 less, and Hannah has 30, that equals 53. Yeah? So if I add those 3 numbers, so j equals 13 pounds, lbs. Okay, everybody. Now let's go look at our last example. And by the way, I did not answer the question, so I should answer the question. It's asking how many pounds did Sophia recycle? Well, we already established that Sophia recycled 10 pounds, right? Because James recycled 13 and Hannah recycled 30. So Sophia recycled 10 pounds. And for the last example, we have to graph the solution on a number line. We have our inequality. We are solving our inequality first by doing distributive property, as you can see, then subtracting the lower coefficient from both sides, leaving us with a simple a minus 8 is greater than or equal to negative 12. Then we use addition property of equality to remove the 8, and a is greater than or equal to negative 4. Because it is equal to negative 4, the circle is filled in, and it is greater than negative 4, so it's moving towards the 0 into the positive numbers, right? And here's our last 2 examples, 5a, 5b. I know you're probably getting tired, but keep in mind that all of these questions will be on the test, so it is important for us to practice these questions. Pause and solve 5a and 5b, please. Here's 5a. Pause now. We should start by doing distributive property, so that we get negative 2k minus 2, because negative 2 times 1 is negative 2, is greater than negative 16 plus 5k. Now we have to look for the greater coefficient, which is on this side, so that's the one we're going to keep, and we're going to get rid of the smaller coefficient by adding 2k. Okay, and I'm going to add 2k to both sides. Addition property of equality. My 2k is gone, and I am left with negative 2 is greater than negative 16 plus 7k. And now I will remove my negative 16 by adding 16, because remember, I want to isolate the k, right? So I want to go in reverse order of operation, and I'm going to add plus 16 to this side as well, which leaves me with 14 is greater than 7k. And now let's use division property of equality to remove the 7. The 7 is gone, and now I'm left with k is greater than, or sorry, k is less than 2. Or when we rewrite it, because we should rewrite it with the variable on the left side, it is k is less than 2. So how does that look on the number line? So on the number line, that would look like a hollowed circle at 2, right? At 2, because it does not equal 2, and k is less than, so it's in this direction, right? So it is not 2, but it is less than 2. And finally, for our last question, let's use distributive property first at the top, so that our next line looks like this. 2p plus 5 is greater than or equal to 3p minus 18, because 3 times negative 6 is negative 18. Now let's identify the higher coefficient, and we know it's on this side, so let's get rid of the one on this side by using subtraction property of equality and subtracting it out from both sides, right? That means that value is gone, and we're left with 5 is greater than or equal to p, right? Because 3p minus 2p is 1p, so just simply p minus 18. Let's use addition property of equality to remove the 18 so we can isolate the p. And we add 18 to both sides. And on this side, the 18s are gone, so I'm left with simply p. And on this side, we have 23, right? So 23 is greater than or equal to p. What does that look like on the number line? Oh, but before I do that, I almost forgot. I should rewrite it as p is less than or equal to 23. Don't forget that when you put your variable on the left side, the symbol has to flip. Remember, this side, the pointy side, needs to follow the p. So if a p goes to this side, so does the pointy side. Okay, so like I was saying, what does that look like on the number line? Well, p is less than or equal to 23. So I'll find 23 and it's equal to it, so I will color it in. I have to make sure it's completely colored in because it could be 23 as well, so that's the marker, but then p is less than, so it goes in that direction. So it's equal to or less than. And that is it for today, everyone. See you in class.